Welcome to 56-Bit Cloud Cafe, your go-to destination for all tech topics in the cloud. I'm Atir Zalat.
And I'm Patrick Camilleri. And together we'll be addressing various cloud topics.
Hello everyone and welcome back to our podcast series. Today we are diving into the world of Amazon Simple Queue Service, or SQS. Now whether you are a developer, system administrator, or just curious about cloud technologies, this episode will give you a solid understanding of SQS and its significance in modern cloud architecture. So let's start. Now, to kick off our series on AWS SQS, let's start with the basics. What is SQS and why is it important in the world of cloud computing?
Thank you, Atir. So yes, Amazon Simple Queue Service, or SQS, is one of many managed messaging services in AWS, and it's used for sending and receiving messages between applications. It acts like a highly reliable queue. It ensures that messages are delivered at least once. And SQS is important because it decouples applications. It makes them more scalable, more fault tolerant, and usually easier to manage because you have an application which is split into multiple pieces, and it allows those applications to talk to each other with a queue, with a buffer in the middle. I like to imagine it as a waiting line where you're waiting to buy something, for example, and the messages are processed one by one, like the people in the line are processed one by one. And that ensures that nothing gets lost in transit.
Okay, perfect. That gives us a good overview. Now, could you dive a bit deeper into the mechanics, like how does SQS actually work?
Right, so SQS works like this. You have an application, it sends a message to an SQS queue using the AWS APIs. This message can contain anything. It can contain any data format like text or JSON or even binary data if you want. There are limits on the amount of data that can be sent, which is 256 kilobytes. But ultimately, that data format can be whatever one wants. So a message is sent to us an SQS queue. SQS will store the message securely and highly reliably over multiple servers and multiple data centers in a specific region. And then a different application retrieves that data, retrieves that message. The receiving application, the one retrieving the message, can be triggered by the arrival of that new message. So you can have a serverless application like a Lambda function, which is triggered by the arrival of the new message. Or you can have a server which is constantly asking for messages. And this makes it a real-time communication channel between applications.
I'm starting to see how powerful SQS can be. What are some of the key features that make SQS stand out from other messaging services?
SQS offers several key features. Probably the most important ones are scalability, right? It allows you to handle up to millions of messages per second without managing any servers. It's completely serverless, that it is a managed service with no infrastructure management required. It allows you to focus on the messages themselves, on the application sending and receiving those messages. It's very reliable. All those messages are durably stored. They are delivered at least once. That is a guarantee that SQS gives, at least once. There is another version, which is the FIFO type of SQS, first in, first out, and in that case, they will deliver it, guaranteed to deliver it only once. It allows us to decouple applications, to increase independence between applications, and that allows those applications to not be a danger to the rest of the application itself. So if you have multiple microservices and one goes down, SQS allows you to have an ability where that single microservices that went down does not affect the others. Theoretically, of course, depending how you architect it. And finally, it's very, very cost effective because you only pay for the messages that you send and receive. There are no servers running. If you don't use it, you don't pay. It's fully serverless. Putting all that holistically, it gives these key features which are very important and also has good competitive advantage over other solutions. There are many other external solutions that SQS competes with. It is one option that has all these features.
Now that we understand what SQS is and how it works, can you share with us some common use cases where SQS really shines?
Yes, so SQS has various use cases. You can use it in whichever way you wish whenever you have an application that wants to talk to a different application. With a queue, with a buffer in the middle. We can use it for microservices communication, where we coordinate tasks between independent microservices. This is one of the features that we've been talking about, that decoupling. This is a top important use case for SQS. But you can use it for batch processing as well, where you can queue tasks, leave them in this buffer, waiting for a processing application to process them slowly, and it gives it enough time for that application to do its thing as a buffer. It allows us to also decouple web applications, so it separates requests from the front end from the back end, and that allows better scalability from an architectural point of view. We can trigger serverless functions like Lambda. So whenever SQS receives a message, it triggers Lambda, and that in turn does something with that message. So we can use it to build serverless applications. And finally, we can also fan out. Fan out is a type of workload and a type of architecture where you send a single message, and that message then gets fanned out using SNS then, right? So you have to use SQS with SNS, and together it allows one message to be sent to multiple applications simultaneously, allowing for different types of processing on that message. So whatever the use case, SQS can probably handle it if you need a queue in the middle. And it's a very good alternative to a lot of the other solutions out there. Of course, everything has its pros and cons, and one has to see one's use case specifically within that context.
And by now, we've covered the basics of Amazon SQS, its importance, functionality, key features, and common use cases. If you found this information helpful, don't forget to follow us for more AWS topics and episodes. Until next time, happy cloud computing!
If you have questions, suggestions, or want to share your feedback, connect with us on social media.
Also, don't forget to subscribe to our podcast and to leave us a review to help others find their way to the Cloud Cafe.